I've got to do this, and now we're recording. So guys, everything that's said for the rest of the day in this room is being recorded. Your questions, my thoughts, the things that we discuss, and then what you'll see is at the end of the day, well, at the end of the hour, I actually compress this into a video that I then post on YouTube and post the link to. So if you need to go back over any of this material, it is there for the rest of the year and you'll always have it as a reference. So guys, what I want to do to get started is rather than dig right into the material that you've got there, let me sort of set the stage for this for you. And so to do that, I'm going to jump out here and go to our website. Actually, I'm going to do it this way. So we're going to go here, and we're going to go here, and we're going to go here. And guys, this is the deal for this first unit. So today we're on Wednesday the 22nd, and you've got the notes in front of you. You're ready to go. You will have homework tonight, and we'll talk more about that in just a minute, well, at the end of the day. But then, guys, when I see you on Friday, you're going to see the homework that you get today, we're not going to grade on Friday. Friday, we're on an assembly schedule. Did you guys know that? We have a welcome back to school assembly on Friday, and so we're not going to grade this homework on Friday. Normally we grade homework the very next day. We're not going to grade this homework on Friday because we need the day to get into lab. So Friday is going to be a great day for you. You're going to come in. We're not going to grade homework. You're going to grab your goggles and we're going to go over to lab, and we're going to talk about lab safety. We're going to talk about some first aid stuff. We're going to break you into lab groups, and we're going to get you checked into lab drawers. So that's Friday. You won't have any homework then over the weekend, which is a beautiful thing. Then guys, starting on Tuesday of next week and for the rest of the unit into September, all we're going to do is teach you how to work in lab. So that's what this entire first unit is about, is how do you work successfully in lab. So with that as a framework, here's what we're doing today. I'm going to just get rid of that. I'm going to go here and here and here we go. So guys, today what we're going to do, what all of your notes are about today. So if you go down to that bottom slide, you'll notice you don't have the advantage of animations. But guys, I would propose to you this, that science is simply the process of observing things that are going on around you and then collecting data, taking measurements, and making sense of your world. So with that in mind, do this. Guys, go down here to this bottom left-hand image that you guys already have in front of you. And here's what be data collectors, we need to start by talking about the types of data that you're going to be collecting. And I want you to start by actually collecting some data. So guys, I've given you this picture in your notes. It's up here on the screen if you prefer to see it this way. And guys, maybe seeing it in color is better than seeing it in black and white. But here's what I want you to do. On your paper with a pen or pencil, write down 5 observations that you see in that picture in the bottom left corner. Do 5. You got about 2 minutes. Frightening, guys, right now, you're doing science. Because this is what science is about. It's the process of observing and gathering data. So guys, 5 observations. Bless you. Do you have enough space to do that? Yeah, you're all right. A little bit of space off to the left or down below. So guys, 5 observations from that picture. By the way, if you're curious to know what you're looking at, that green mesh is actually a computer-generated representation of an enzyme. And that enzyme is actually attacking a biologic molecule and ripping it apart. But you don't need to know that. You just know it's green and lumpy. And here, I can actually zoom into it too if that's helpful. So again, guys, 5 observations. Hey, good morning, guys. I left the notes pages for you back there, and we're actually down in the bottom left-hand corner. I printed your notes for you today. So we're down in the bottom left-hand corner of the page, and we're just writing down 5 things that you see in that picture. It's also up on the wall. So guys, let's go for about 20 more seconds. If you don't quite have 5, that's fine. Get as close as you can, but wrap up your last thought in the next 10 or 15 seconds, and then we're going to sort of gather and figure out what we're to learn from this. So guys, again, up to maybe 5 observations from that picture. You guys okay? Did you get close? So Madeline and Sage, you guys can just sort of fake it, but you'll see, you'll be fine. So guys, here's what I want you to do. Grab the person next to you. If you're like these guys and you don't have a person next to you, you guys can sort of do a clump of 3, and that's totally fine. But guys, what I want you to do is I want you to compare notes. And please, if they've got something you don't, add it to your list. So grab the people next to you, immediately next to you, and then like if you want to just go that way, Sam, that would be fine. Add their thoughts to your list if they've got something you don't. If it's close, that's fine. Talk to your neighbor. What do they got? Compare notes. Nice. You're getting good at right and left-handed, I think. Yeah. You guys okay? Okay. Eek. So guys, about 20 more seconds. I have to tell you, that's the best pencil sharpener in the whole school. Oh yeah, try it out. Did I tell you? Okay guys, let's bring this back together. It was fun for me to sort of float around, and can I just tell you right now, this is weird. Like this is, you guys know this, right? This is my 26th year of teaching. I've never taught this material this way. So Miss Call and I are actually in the process of revamping the way that we sometimes introduce material to students. And I got to be honest with you guys, I got up this morning and the first thing that went through my mind was, oh crap, this could go horribly wrong. I have no idea how today is going to turn out. This could be a total train wreck. So, so far so good. But this is completely experimental. So you don't know the difference, but for me, I'm going, oh boy. This was actually Miss Call's idea, so I can blame her if this belly flops. But here we go. Okay, so guys, you had the opportunity to gather around some observations about this picture, even though you had no idea what this picture represented. Now guys, what I would propose to you, and you have this in your notes so that you don't need to write it down, but if you have ideas rattling in your head as we talk about this, you certainly have room to write those down next to the stuff I gave you. So guys, what you're going to find in science, and this just isn't in chemistry, but what you're going to find in science is that there's actually 2 types of information, and these are terms you need to know. Do you see them down below? They both start with Q. Do you see them? Guys, you may want to underline those terms because those are important words. So you have the definitions, but bless you, let's talk about them. So guys, the first term that you have there is quantitative. Now, because we're all budding young, like students of English, guys, what is the root word of quantitative? Quantity, right? And so guys, when we talk about quantitative data, we are talking about data that is derived from measurement or counting, and it always involves a number with units. Guys, I would underline that second bullet point. It always involves a number with units. So if it's quantitative data, it's a measurement and it involves a number with units. Then guys, qualitative data is the other other type of data that we'll encounter. This is descriptive data. It's derived from observation, and it is descriptive in nature, which makes sense because the root word for qualitative is quality. What are the qualities? It doesn't mean quality like good. It means quality like what are the qualities of what you're observing. So guys, with that said, here's what I'd like you to do on your own. Go back through your list of all the observations that you made and put them in a category. You could write qual and quant. You don't need to write it all out. And you'll even hear us call qualitative data qual data. So guys, what I want you to do is in your list, I want you to classify your observations as qual if it's qualitative data, or quan if it's quantitative data. Do that quickly in your notes. Qual and quan. Get a chance to do it? So guys, let's talk. And if you don't mind, I'm just going to call some of you out. Forgive me if that's not okay, but I'm going to do it anyway. I'm curious to know what you came up with. So Cooper, if I could interrupt, I know you're still writing, but give us a quantitative observation that you came up with from the picture. No, you had no quantitative observations. Which one? I'm sorry, say it again. Perfect. So give us a qualitative observation then. There's a what? Oh, perfect. So there's a group of spheres down below, and he's describing what he sees. Would you all agree that that's qualitative in nature? Holly, did you have any quantitative observations? Good. Give it. Beautiful. Okay, so let's talk about that. What is it in, she said there's one red sphere. What is it in that observation that makes it quantitative? One, right? She counted something. But remember, it's not enough to just have a number. You have to have units. What are the units? Red spheres, right? She's identifying how... No.
Guess what day it is?
Do you guys know about this? What day is it?
Day.
Do you guys know about that Geico ad? It's Geico happier than a camel on hump day. Have you guys seen the ad? I'll show it to you at the end of class. So if you have me on Wednesdays, just assume that Miss Shaw is going to come in and do the hump day thing because it's what we do. It's lovely. Anyway, so guys, back to Holly's thought. So guys, check this out. So she said one, right? So now we've got a number, but if we think about the definition, it has to have units, and Stephen suggested that the unit was red spheres. Are those units? Absolutely. You're identifying what that thing is, so Holly, I would certainly agree with you. That would definitely be a quantitative piece of data. But what about this? Could it also be qualitative? What part? The red part, right? Because now it's descriptive in nature, absolutely. So you might even be able to argue that it's a little bit of both. So I think that's great. Jason, Jason, did you have a quantitative?
Yeah.
Did you? And give it to us.
There are 18 white spheres.
Beautiful. So again, guys, we've got 18, we've got units, so let's go, Sage. Sage, give us a qualitative observation, please. Are you starting to get it? Is this okay? That's lovely. Notice that she's describing what she's seeing. She's describing colors. Maybe some of you really got into this and said the green thing is surrounding, but so qualitative is descriptive, quantitative is numerical. Do you get the idea? Do we need to talk about this anymore? Is that okay? Okay, so guys, if that's the case, what I'd like to do is I would like to switch the game on you, and we're now going to come down here and we're going to look at this picture. Forgive the Mountain View Bruin colors. I didn't think about it when I threw it in there. But he does have a yellow helmet, so we'll count that a little bit. But guys, let me offer you an observation now, and you tell me which one it is, qualitative or quantitative. You ready? Here we go. So one of the observations I would make on this picture is the football player's jersey has the number 24 on it. Qualitative or quantitative? Come on, guys, it's got a number, right? Didn't we agree, if I zoom back out, that if it's got a number, that would make it quantitative, the number 24? Don't let me bully you. Guys, why am I wrong? Why is this not quantitative? Because it's not units. Guys, numbers can also be descriptive. When I said the number 24, did I measure or count anything? No, so consequently, that is not a quantitative observation. So don't let numbers fool you. Sometimes numbers are descriptive. The question is, where do the numbers come from? And for them to be quantitative, it's got to be a measurement, or it's got to be counted, it's got to be a number, it's got to be units. Can I get an amen? You guys okay? Are we good on this idea? Okay, so guys, here's what I need you to do. Mentally, we're going to make a transition. So if you watch my hands, this will help. You guys now are telling me you understand qualitative and quantitative, right? Okay, here's what we're going to do. You're going to put qualitative in your mental back pocket. Qualitative is going to go away for the rest of the day, and everything we're going to talk about for the rest of the day is about quantitative data. You guys need to switch the page, right? Is that true? Yep, okay. No, you don't. No, you're down at the bottom, right? No, you're just down at the bottom. Don't switch the page. So guys, everything that we're going to this out, this is subtle, don't miss this. What we're going to talk about now is the quality of quantitative data. But guys, now quality means how good it is. You ready? And this is where I didn't give you much, right? Oh, I gave you the words, but I didn't give you the definitions, so be ready to write. So guys, here's what we're going to do. You're going to find out that we are going to use two different terms to describe the quality of quantitative data. Now we mean how good it is. So focus on the word quantitative. That means measurement, counting, numbers, and units. So now we're going to talk about how do we communicate how good our measurements are. So guys, you'll notice down below, you've got two terms and then you've got three bullseyes. Guys, here's what I need you to do. In these bullseyes, please label them. The left-hand bullseye will be your first term, which is precision. Write precision underneath the left-hand bullseye. Then guys, the middle bullseye will be accuracy. And then the right-hand bullseye will be both. Okay. So guys, here's what we're going to do. We're going to talk about the word precision. So what I'm going to do is I'm going to stand back here with my fictitious gun, and I'm going to fire 5 shots at this bullseye. Okay, and I'm not going to give you the definition of precision, but what I will tell you, you wrote precise, that the 5 shots that I'm going to fire are going to be precise. And then you are going to come up with the definition for precision. So write down these shots with me. You ready? Watch the bullet on the left. And by the way, you guys all understand, what am I shooting for when I'm shooting at a target? The red part, right? Okay, so here we go. So guys, 5 precise shots. You ready? Watch the bullseye. 1, 2, 3, 4, 5. Guys, write them on your target. You do that with me. And then guys, let me tell you, those 5 shots are very, very precise. But I never hit the bullseye, did I? So guys, what does precise mean? Go ahead. Good. It's Ben, right? Yeah, say it again. It's the exact same place every time. Guys, precision does not mean correct. You can be very precise and very wrong. Precision, and Ben, feel free to use your own words if you have another way of thinking about this. But guys, fundamentally, you've got to understand that precise means well grouped or repeated. It doesn't mean right. So you can be very precise and be really wrong. For some of you, this is like your life story. I keep doing the same. So all you have to do if your parents start calling you on it is just tell them, Dad, I'm just precise. Come on. All right, maybe not. So guys, again, precision just means well grouped. It doesn't mean right. And guys, if we're making measurements, being precise on its own is not good because it could mean all of our measurements are wrong. So now let's talk about the other word we need to understand, and that's accuracy. Guys, we're going to change the game this time. I'm going to give you the definition of accuracy, and then you are going to fire the shots. So guys, accurate means correct. So guys, what I would like you to do, please, is now in the center target, place 5 accurate shots. Does it make you nervous when I walk around back here? I don't know why I do this. It just makes me feel like I really have a gun. I know, it's weird. Okay. So, guys, you're not going to like this, but check this out. Ready? Independent of what you drew for your center target with your accurate shots, guys, this is perfect because I did this on a computer and computers can allow you to do this well. Guys, I'm going to show you 5 perfectly accurate shots on this target. You ready? You're not going to like this. 1, 2, 3, 4, 5. Those 5 shots are perfectly accurate, and yet I never hit the bullseye. Can somebody put that together for us? How can that be? Gabriella, what do you think? Yeah, take a guess. That's the fun of this. We get to guess. Go ahead. That's not a guess. That's exactly right. Guys, check this out. We understand that our goal is the center of the target, right? And I never hit the center of the target, but I really love the way Gabriella explained this. Guys, look at where these shots are relative to the center of the target. They are all evenly spaced around the center of the target. Now guys, watch the screen really closely. I love that I can do this electronically because guys, if you don't see it yet, don't blink because this goes fast. Watch. So what Gabriella is telling us is that these points are evenly spaced around the center of the target. If you don't understand, watch this. If we bring those points together, where do they all meet up? Right in the middle. What do we call that mathematical process of finding the middle of things? Finding what? An average. What I just showed you is a visual representation of finding an average. And guys, the magic thing is this. When we collect data, if we collect multiple pieces of data, then we can take an average, and the average is always more accurate than any of the data points because averages always close in on the actual answer. Do you get it? Crazy, right? Gabriella, that was awesome. Okay, so guys, here's where we are. Precision means well grouped, but on its own it could be wrong. Accurate means correct, but any single point of data doesn't have to be accurate, which is why we will make multiple measurements and take averages. But guys, we're going to bring both together. Because while, yeah, it's good to be precise, it could be wrong. And while it's good to be right, those data points before weren't precise. They weren't well grouped. So guys, what we would like to do is be both. So here's what I want you to do. In the bottom right-hand corner, please write 5 shots that are both accurate and precise. Do it now. 5 shots that are accurate and precise. Some of you aren't. Same thing. You guys ready? 5 shots, right-hand target, accurate and precise. Ready? 1, 2, 3, 4, 5. Did all of you do that? Jason, did you do that? Just one shot? Yeah, so Jason, explain that to us. What's going on? So let me set this. I said 5 shots. That looks like 1. What's going on? They're all in the same hole. Guys, that is your goal as a quantitative data collector. You want to be getting the same correct answer over and over and over. Think about that. The same correct answer over and over and over. Correct makes it accurate, over and over and over makes it precise. And that's your goal when you're collecting data, is to get the same accurate result precisely over and over and over. Now what questions do you have? Are we 2 for 2? So guys, we talked about qualitative and quantitative, right? Which one did we put away? Qualitative. And then we focused on quantitative. And then guys, we just had this conversation about the accuracy and precision of quantitative data. And now we're comfortable with the idea that we want to be both. We want to be precise so that we get the same results, but we want to be accurate so that our results are correct. You guys good there? Okay, watch my hands again. So we went qualitative, quantitative. We put qualitative away. We focused on quantitative. We said quantitative data should be accurate and precise. Good? Okay, now here's what we're going to do. We're going to put away precision. If we put away precision, what's left? Accurate. And guys, now what we're going to do is this. We're going to have a whole different conversation, and we're going to talk about how we communicate accuracy in measurement. Do you understand that flow? So accurate means what? It could be from an average, but what does it mean? Correct. So guys, we are now going to talk about how do we communicate the correctness in a measurement. So we're going to go into lab next week, and you're going to be making measurements, and you're not only going to be collecting data, you're going to need to tell the world how accurate your data is, how correct your data is. And the question is, how do you do this? So guys, I have the advantage of animations. You have this on your slides in the next slide down. Be ready to write down some data. You ready to go? Okay, check this out. This is one of my best pieces of work. So guys, this is simply, actually I can show you. Where did it go? Oh man, someone stole it. This is actually a cute little plastic chunk of plastic, but somebody took it from me, so never mind. So, guys, imagine that you are given some chunk of some just plastic stick. And the question is how long is that stick? And we don't measure in inches because centimeters are science units. And so, guys, we're going to measure the length of this stick in centimeters. Now, guys, if you're not familiar, let me just show you. A centimeter is about the width of your pinky. A centimeter is actually this long. So we're going to measure the length of this stick in centimeters. Now, watch close. Here's what we're going to do. We're actually going to do it 3 times. You see that? All right, you want to see it again, huh? This was hard. This took me a long time. So 3 times. Same stick. We're going to measure it 3 times. Sometimes the little things mean a lot. So, guys, we're going to measure the length of this stick 3 times. So in order to do that, we're going to bring in a scale. So in order to make a measurement, we need a scale. So the first scale that we're going to use actually looks like this. So the first scale that we are going to use is actually broke into 10 centimeter chunks. So 10, 20, 30, 40, and we're going to make a measurement on this scale. So guys, relative to this scale, and please write this down with me, the measurement that we would take would be 10 centimeters. Now, what we're going to do now is we're going to do this measurement on a little bit better scale. So the first measurement we made is on a 10 centimeter scale. Now we're going to do it on a 1 centimeter scale that is also represented on the board. And against this scale, the measurement that we could make is 10.0 centimeters. But then, guys, we can do better than that. With a better scale, we can actually get a different measurement. So we started with tens of centimeters, individual centimeters. Now we have tenths of centimeters. Do you guys know the name of tenths of centimeters? Millimeters. So guys, now we're going to make this measurement in tenths of centimeters with a better scale, and the number that we would then record is 10.00 centimeters. So guys, here's the question that I have for you. Which one of these numbers is bigger? Top, middle, or bottom? Which one's bigger? That's a trick question. Which one's bigger? They're all the same, right? It's 10 and 10 and 10. They're all the same measurement. But they're different because the scales are different. So guys, I have a question for you. Do you have this in your notes? Oh, I'm good. Okay. So guys, this is the question I would like you to try to answer. When you make a measurement against a scale, against something like a ruler, when you make a measurement, how do you know how many decimal places you can record? There's a pattern to these measurements. See if you can figure it out. I'll give you about 45 seconds, then I'll have you chat with your neighbor, and then we're going to talk about it, because this is important. You're going to be held accountable for this for the rest of the year. Why is it we went 10, 10.0, and 10.0? Figure it out together. Okay, so guys, I think I've given you enough time to process. Frankly, one of the things that I've learned from being married almost 20 years is not everybody thinks at the same rate. As a teacher, I've just trained myself to just words come out of my mouth. My wife is totally different. Like, I'll ask her a question, and she just like, and you're like, oh my gosh, did she hear me? Is she having a stroke? What's going on? And then like 5 minutes later, she'll come back to me and answer the question. I'm like, good night. My wife is a processor, and I'm learning that some of you need time. So have I given you enough time to think about this? So guys, what I'd like you to do is grab again the person next to you and come up with an answer. And again, if you're like Sam on your own, if you wouldn't mind sort of combining your, if you're comfortable, if not, that's okay. But guys, what's the pattern? What's the rule? What's the talk? Did you just say decimeters? Nice. That's good. Yeah, you're exactly right. Guys, we're going to go for about 15 more seconds. So guys, final thoughts and we'll come back together. You guys good? I'm really looking forward to what you guys come up with, because I think this is going to be hard to describe even if you see the pattern. A little too comfortable. Autumn, will you take a swing at it? What's the pattern? What's the rule? Oh, good. Okay. I think I think there's probably something to that, but I'm fearful to run down this idea of powers because we may lose people in the process. Go ahead, Ben. Yeah, and I think you're right on it. Guys, the answer is this, and let me show you what I think Ben, and I suspect many of you see. Guys, it's all about tenths. So check this out. So guys, what are the units on this top scale? Well, this is 0 and this is 10. So guys, this scale measures in tens. So if this scale measures in tens, then we will estimate down to ones. That is a tenth smaller. Now guys, check this out. So this is 0 and these are ones. So guys, this thing measures in ones. So if it measures in ones, we will estimate a tenth smaller. So what is a tenth of 1? A tenth. So that means we will estimate down to 1 decimal place beneath that, so we'll estimate to the tenths. Now guys, check out the last scale. This is 0, and these are tenths. All these little marks are tenths, and so if we go 1 space below the tenths, what's 1 space below the tenths? Hundredths. So guys, with that in mind, check out how this works. So if this measures in tens, we go, okay, that's 10. But if we want to estimate below that, we go 9 and we go 11. That's 1 above and 1 below. So is the length of this stick, is it 10 or is it 9 or is it 11? It's right on 10, so we call it 10. So now guys, with this middle scale, we go like this. We are now measuring in ones, so we'll estimate tenths. So we ask ourselves, a tenth below is 9.9, a tenth above is 10.1. And so we ask ourselves, is that 9.9, is it 10 or is it 10.1? Well, it's right on 10. But guys, if we just recorded 10, that doesn't tell your reader that you're actually looking for tenths, because if you're measuring to ones, you can estimate tenths. So what we have to do is go, yeah, it is 10, but we looked for tenths and didn't find any, so we call it 10.0. You see that? So now guys, when we come down to this bottom one, these little lines down here are the tenths. So we know that it's 10 and we know that there aren't any tenths. But then we look for tenths of tenths, which are hundredths, and we go, no, that is not even a hundredth above or a hundredth below. It is exactly 10 all the way out to hundredths, and so we call it 10.00. So guys, bottom line is this, and this is what you need to write down. It's not in your notes. The fundamental rule is this. When you're measuring against a scale, always estimate 1 decimal place past the accuracy of the scale. So if the scale measures in tenths, you'll measure hundredths. If the scale measures in hundredths, you'll estimate thousands. If the scale measures in ones, you'll estimate tenths. So guys, this is another good time after you're done writing that down to talk about questions. So we've got some big ideas in the room. We understand qualitative and quantitative data. We understand that we describe the quality of quantitative data using accuracy and precision. We understand that then, in order to communicate accuracy, we need to make measurements appropriate to the scale, and we do that by estimating a tenth past the accuracy of the scale. So guys, 3 big ideas. Any questions about any of this? If not, we got one more thing to talk about. You guys okay? All right. You're sure? Promise? You guys will ask questions if you need to, right? Okay. All right. So guys, last thing we need to talk about then is this. Watch what happens. I frankly don't know what I gave you in the notes. Do you now have this? With the scale gone? Sort of. It's on the next page. I should have deleted the scale in your pictures too. So guys, go to the next page. Imagine that the scale is gone. Here's the question that I have for you. If the scales were gone, and if you were just presented with these three measurements, and again, we've already determined they all have the same value, right? They're all 10. Here's the question I have for you. If you hadn't seen the scales that were used to make these measurements, which of these three measurements would you be most confident of? Which one of these three measurements do you think is the most accurate? Again, we have a sense of it because we saw the measurements being made, but if you hadn't seen, which one of these measurements would you be most confident of? And importantly, why? Let me give you a second to think about it, and then we'll talk. Just a second, Ben. Which of the three measurements would you be the most confident of, and why? Give you a second to ponder. Lauren, what do you think? Of top, middle, bottom, which one do you, just from looking at the numbers, which would you say is the better measurement? The bottom one. Why? But here's the thing that's interesting. You know that because you saw that and I like the word exact or maybe accurate, but you know that it's the most accurate because you saw we did it with a better ruler, right? But imagine if you hadn't seen the rulers, and I totally agree with you, but if you hadn't seen the rulers, what about that bottom measurement tells you that it's the most exact? Yeah, do you guys see that? Guys, focus with what Lauren's talking about. Guys, check out these zeros. These zeros are critical, and let's talk about them. This is the last big idea of the day. Guys, these zeros are critical, and let's talk about why. Guys, do these zeros, but we're talking about these. Do these zeros change the value of the number? 10 and 10 and 10. They don't change the value of the number, but why, Lauren, are you saying that that bottom number is a better measurement? Exactly. Guys, this bottom measurement has more information contained in it. And it's not information about bigger, because all three of these numbers have the same value. So those zeros don't communicate size, they communicate accuracy. They're telling you that this is a better measurement because we looked for tenths and looked for hundredths and didn't find any. Do you get the idea? Because this is the last big idea of the day, and this is critical. So this is the idea. Are these zeros important? Absolutely. Why are those zeros important? Guys, these zeros are important because they communicate accuracy. And those zeros are so important that we give them a name, and it's actually the title for it's at the top of your next slide. Guys, these zeros are so important that we call them significant. These are what are called significant digits. And guys, these are numbers that communicate accuracy. Now guys, you've done significant digits before. Yeah, I think so. It used to be a Leos that taught physics and last year. So this is brand new. I think all of me just tell you guys, this is a really big concept. You're going to be doing these for the rest of the year, and you need to sort of wrap your head around this now. So here's where we are. When we make measurements, there are digits that don't communicate size, they communicate accuracy. And we call those digits significant digits. In your notes, you'll notice that we've given you a bunch of numbers. You have these right. We've given you a bunch of numbers, and off to the right, we've given you the number of significant digits or significant figures, Sig Figs. We've given you the number of significant figures in those numbers. So every underlined digit is a significant digit, an accuracy digit. What's the pattern? Guys, there are rules. There are 3 kinds of significant digits. And by looking at the examples that we gave you, I want to see if you can figure out which digits are significant. But guys, to help in this process, do this with me. Watch the board. Guys, what I want you to do is draw 2 lines in your notes. Draw one this way and draw one that way. Obviously in the same places. Guys, what you're going to see is that the examples that we gave you are grouped together to show you examples of the rules for identifying significant digits. So guys, see if you can see the patterns. In the upper left-hand corner, what do you see that makes a digit significant? In the bottom left-hand corner, what do you see that makes digits significant? In the upper right-hand corner, what makes digits significant? And then, guys, what about the bottom right corner? Gather your thoughts, and then we'll go over them. We're looking for patterns. Bless you. So guys, let's talk about it. Upper left-hand corner. We've got 2 significant digits, 3 significant digits, 2 significant digits. What is true of all of those numbers that are significant? And you'll notice that importantly in this example, we showed you one that's not significant. So guys, what's true of all of these numbers? What aren't they? Do you see it? Which one of those numbers is not significant? The 0, right? What about all these other digits? They're significant. Those are accuracy digits. And so guys, the rule is this, and you can write it down with me. Non-zero digits are always significant. Those are digits that will always communicate accuracy. So non-zero digits are significant. So 1 through 9, and guys, at the end of the day, you've got to be able to count how many significant digits are in numbers. So 1 through 9 is always significant. But now, guys, what about down here at the bottom left? Well, let's check this out. So here we've got 3 significant digits, but that makes sense because it's a 4 and a 7 and a 2. That was our first rule. But now look at this one. We've got a 4, a 7, a 2, and a 0, and then we've got an 8 and a 2 and a bunch of zeros, and those zeros are now significant. So guys, the question is, and doesn't that look like the zeros that were in our 10s that Lauren was talking about, right? So guys, what is it that makes these zeros significant? And this is the way that we say it. Final zeros after the decimal place are significant. So final means at the end of the number, and after the decimal just means on the right-hand side of the decimal, and those zeros are significant. And again, guys, your goal today is to be able to count how many significant digits are in numbers. And I'll give you some examples in a minute. So guys, now we know there are 2 kinds of significant digits, non-zeros and final zeros after the decimal. So now, guys, let's go into the upper right-hand corner. So all of these digits are significant. But guys, look at the zeros. Are those zeros final zeros after the decimal? No. So what's the pattern here? What makes those zeros significant? Yeah, do you see it? That's true, but so do these. It's not quite that simple. Go ahead. Just a second, Jason. Go ahead, Stephen.
They have a number that is of significance after the zero.
They're trapped. Yeah, and not just after, but before and after. Guys, this 0 is trapped between a 5 and the 9. And the 5 and the 9 are significant, so the 0's trapped. Here, these zeros are trapped between the 8 and the 3, so they're trapped and therefore significant. And the same thing here. So guys, the third rule is this. Trapped zeros are significant. Bless you. And then, guys, you're not going to like rule number 4. It basically goes like this. No other zeros are significant. And so, guys, what I'd like to do is I'd like to talk with you about why these ones in the bottom right-hand corner don't count. So, guys, let's take a look at these zeros. Let me switch to blue or to red. Guys, these zeros right here, are they at the end of the number? Yeah, so they are final zeros. But why are those zeros not significant if they're final zeros? Why not? They're not after the decimal. So, guys, what about these? Are those guys after the decimal? Yeah, but why aren't they significant? They're not final. And then, guys, the same thing is true here. So the bottom line is this. When you need to be able to identify significant digits, there's only 3 kinds of significant digits. There are non-zeros, final zeros after the decimal, trap zeros, nothing else counts. Can you guys do that? All right, so here's the deal. Let's look at some examples. So, guys, it goes like this. Here's those rules re-summarized if you need them. But guys, it goes like so. You ready? And there's a link to this in your notes. But guys, this is like the world's worst video game. Check out the screen. So you ready? You click on new number, it generates a number, and then we're going to tell it how many significant digits, and then we check our answer and see if we're right. So here we go. So guys, what about, let's find one that'll be, what about that number? How many significant digits are in that number? 5, because none of them are zeros, right? So what we do is we go over here and we go 5 and we go check answer and it says correct, and that's as good as it gets. So now guys, let's try that one. Here we go. So what about the 7, the 5, the 8, and the 2? Are they significant? Yeah, what about those 2 zeros? Why? Final zeros after the decimal. So how many significant digits do we have? 6. Check our answer. 2 correct. Good for us. All right, so let's try this one. So the 2 and the 5 and the 7 are significant. What about that 0? Is it a final 0 after the decimal? No, it is after the decimal, but it's not final. So is it a trap 0? No, so it's not significant. So how many significant digits? We got 3, and we check our answer, and we're 3 for 3. So what about, ooh, this is like graduate level. Ready? The 3, and the 8 are, what about those zeros? Why? Final zeros after the decimal. What about that dude? Why is that significant? It's trapped, so that would be how many? 6. And we're doing good. So now, guys, we know that one, we know that one, we know that one. This random number generator is not being very random. Come on, give us something good. Man. How about that one? All of them? Final zeros and a trap 0? But guys, what about this math? Oh, what about that? Is that 0 significant? No, it's not a final 0 after the decimal, and it's not trapped. But guys, what about this? What does this mean? Do you guys know this from the quiz we took last time? What does the E mean? Yeah, it means scientific notation. So guys, let me rewrite this for you, and then we'll talk about it. So guys, this number actually means this. 2.1661 times 10 to the negative second. So how do we do significant digits for numbers that are in scientific notation? All you got to do is look at that. So how many significant digits are in that number? All of them. So guys, if you have a number in scientific notation, all you got to do is look at the base number and not the exponent. You get the idea? So if you need more practice, the link is there. But guys, we've got one more thing to do, and you've got this in your notes, and we're going to wrap this up. So guys, any questions about identifying significant digits? Okay. So guys, here's what you've got to be able to do with this. You've got to be able to round. So guys, this is in your notes. It's the very last page, and we're going to go through these together. So I would encourage you to do these with me. But guys, let's talk, because this is what you've really got to be able to do. So guys, check this out. The number in the top left-hand corner, 314721. Guys, how many significant digits are in that number? 6, right? All of them are significant. But now what we're going to do is we are going to round those 6 significant digits to 4 significant digits. Here's how you do it. Guys, do this with me. Start on the left and underline the first 4 significant digits. Got it? Okay, now, you guys understand rounding rules. Look at the next digit, and it's a 2. Does that round up or does that round down? Does 2 round up or down? It stays the same. It rounds. So guys, what we're going to do is this. We're going to go 3, 1, 4, 7. So that is that number rounded to 4 significant digits. Now guys, what if we do this? What if we take the 2 and the 1 and we round those down and replace them with zeros? Why is that wrong? Because those are significant digits, and that makes 6. Do you see it? So guys, when you are rounding numbers below the decimal place, you do not replace with zeros, because those would be significant digits. So that would be the answer to number 1. So now guys, let's do this one middle top. Are these zeros right here significant?
No.
They are not. They are not final zeros after the decimal. They're not trapped. They're not significant. So guys, how many significant digits are in that number? 4. The 1, the 7, the 7, and the 5. What we're going to do is round it to 2 significant digits. So it's the same game. Underline the first 2 significant digits. Now look at the next digit. It's a 7. Does 7 round up or down? It rounds up, so that means that this 7 is going to become an 8. So we're going to go 0.0018, and that would be that number rounded to 2 significant digits. Again, you'll notice that we don't replace the 7 and the 5 with zeros, because that would be significant digits, and that would make it 4. How are we doing? So now guys, let's look at the third example. 8092. Is that 0 significant? Yeah, how come? It's trapped. Good, good, good. So guys, that 0 is trapped, so that would be 4 significant digits. Now we're being told in parentheses to round it to 2. So we go 1 and we go 2. Now guys, we look at the 9. Does the 9 tell us to round up or down? 9 tells us to round up, so the 0 becomes a 1, and we go 8 and we go 1. Now the rules change. Guys, now we do replace the previous digits with zeros. How many significant digits are now in this number? 2, because those are not final zeros after the decimal. And guys, if we didn't put those zeros, then we would take 81,000 or 8,100 and turn it into 81. So in this case, we do need to replace those with zeros. So it would be 8100. So guys, let's pause for a second. What questions do you have? then what I'd like to do is this, guys. We're actually doing great on time. I'd like you to take 10 or 15, 20 seconds, 30 seconds if you need. And if you need to talk with somebody about this and go, hey, I need clarification on this, guys, get with your neighbor and clarify questions for one another. And it doesn't have to be the person right next to you. I know that, Jason, you're helping, and that's great. So, guys, talk with one another if you need. Get your questions answered, or at least come up with your questions so we can talk. Chat for a minute if you need. Ten more seconds, y'all. So guys, let's try this again. Now that you've had the opportunity to verbalize and talk this through with the folks around you, what are things that we can talk about corporately to help clarify? Questions, things to chat about, please. Yes. Are we talking about this guy? Oh, down here? Oh, you're working ahead. No, you're fine. I want to talk about that one because that one's tricky. Let's talk about it in just a second. Guys, questions over what we've gone over so far? We okay? Okay, let's do the last three, and I do want to talk about that last one. It's different. So guys, now we've got a number down here in scientific notation. How many significant digits are in that number? All of them, right? The 4, the 3, the 6, the 2, the 2. Now it's telling us to round it to 3 significant digits. So to round that to 3 significant digits, we go 1, 2, 3. What direction does the 2 round? Down, stays the same. So we go 4.36. And then, guys, that's times 10 to the negative 5th. Don't forget to add that. But then, guys, what do we do with these 2's? Do we replace them with zeros, or do we get rid of them? Get rid of them, because if we replace them with zeros, we'd then be back to 5 significant digits, and that's not what we want. Is that okay? So now, guys, let's go here. Are these zeros significant? They are, because they're trapped. Even though there's a decimal, they're trapped between the 8 and the 7. So they are significant. So guys, we need 3 significant digits. So we go 1, we go 2, we go 3. Which way does the 7 tell us to round? Up. And we go 8, 0.1. And then do we replace with zeros at the end? No, because those would be significant. You guys ready for the really hard one now? Watch this. Is that 0 significant? Why? Trapped. Is that 0 significant? It is not. It is not a final 0 after the decimal. It is not trapped. So that number has 3 significant digits. And now we're going to round it to 2. So we go 1, we go 2, right? Now, which way does the 4 tell us to round, up or down? Down, or stays the same. So we go 1, 0. But now do we replace those digits with zeros? We do, because if we don't, we take 1,000 and turn it into 10. So we do replace those zeros, and that should be the number to 2 significant digits, but it's not. This is only 1 significant digit. So what broke? Well, guys, why was that 0 originally significant? It was trapped. But now it's not trapped because that 0 is not significant. So guys, here's the $10,000 question. How do we take 1,000 and make 1,000 2 significant digits? Well, so what if we did this? Now how many significant digits? All of them, right? Because they're all trapped. That's a final 0 after the decimal. Those 3 are trapped. So how then do we put this thing into two significant digits? Mara, did you come up with it?
I don't know. The one I got was 18
And that's the trick. We put it in scientific notation. So guys, what we do is this. We take the decimal place and we move it there, and we went 1, 2, 3 places. So this is actually also written as 1.3 times 10 to the third. And when we write 1,000 as 1.3 times 10 to the third, then that 0 becomes significant because it's a final 0 after the decimal. Tricky, right? But that's how to do it. How'd you guys do? So guys, tons and tons and tons of stuff, right? So here's how we're going to wrap up the day. Guys, this is your homework, but don't go, oh crap, that's a lot of homework. Guys, what I do is I give you your homework one unit at a time. So this is all of your homework for the entire unit and not just for today. But what I would like to do is I'd like to talk with you about it so you understand what to do. Again, guys, this will not be graded on Friday. It should be, but because it's an assembly, we don't have time. We'll grade this next Tuesday. And that gives you a ton of time to come and ask questions if you need. Guys, put this in the homework section of your notebook. You'll notice I poked holes in it for you. So guys, looking at the front of this assignment, it just says how many significant digits are in these numbers. Then down below, notice what it says. Rewrite the numbers above representing the requested number of significant digits. Let's do one together. You ready? Look at 71. How many significant digits are in that number? 2. Write it down. And you're going to do that for all of them. Now guys, go down below. And you'll notice down below in the upper left-hand corner, the number 1 is in parentheses. What's that telling you is take the number above, 71, and round it to 1 significant digit. So if we take 71, and if we want to round 71 to 1 significant digit, well, this is our first significant digit. Which direction does the 1 round? It stays the same, so we end up with 7, but do we replace the 1 with a 0? We do, because that maintains the value of the number, so the answer would be 70. And you'll do that for the rest of them. Then on the back, guys, there are 4 questions for you to answer. And we will grade this when I see you next Tuesday. So guys, on Friday, if you didn't bring your goggles today, make sure you bring them. We'll get those left in your lab drawer. You won't carry them around with you. Guys, I would love to work through this homework assignment with you if you need. Just swing by before or after school. Next week, we will have Pride, and I'd love to bring you in. But guys, these significant digit things are important. Make sure you get them nailed down tight. So guys, thanks for a great morning. Madeline and Sage, I need to talk with you guys about, well, here, let me stop recording and then we'll just talk, because you weren't here to record your homework stuff. So guys, if we have like 5 minutes left, if you want to start on the homework, and we'll go when the bell rings.